Okay, let's continue on with the notes. This is another example of how you would use the sum and difference formulas. They're telling you that sine of angle x is 3/5, cosine of angle y is 5/13, and that x and y are positive acute angles. So it says find the cosine of x plus the cosine of y. Now, the cosine formula for the sum involves cosine and sine of both angles, which I don't have yet, but I can easily get those. What I'm going to want to do is make myself diagrams for angle x and for angle y, fill in my missing parts. So let's take it step by step. Angles x and y are positive acute angles, so they're telling me right here what quadrant my angles are in. If they're positive acute, that means they have to be in the first quadrant. So I'm going to draw them separately. Here is angle x right here, and then here is angle y. And I just do this for illustration purposes. I'm a very visual person, so it helps me to visualize what I'm actually looking at. If the sine of the angle is 3/5, remember sine is opposite over hypotenuse. So here's my angle x. The side opposite is 3, the hypotenuse is 5. If you recognize that that's a Pythagorean triple, then you know that this side down here has to be 4. Remember that this is a right triangle. Okay? And same here, the cosine of y, so that's going to be adjacent over hypotenuse. And again, if you recognize that's a Pythagorean triple, you know that missing side has to be 12. If you didn't recognize that, then you can do Pythagorean theorem to find that missing side. Okay, so now I've got all of the sides in both of my triangles, and now I'm going to set up my formula. The cosine of x plus y, the formula says the cosine for the sum. So go back to your formula. Cosine for the sum. Cosine of the first, cosine of the second, minus sine of the first, sine of the second.
Okay, now that we're to this step.
So the cosine of the first,
So look at what we did. Whatever we're adding
cosine
or
of the
subtracting
second,
to
minus
the next term, we do the opposite.
sine of the first, sine
Where are
of the
we
second.
adding or subtracting to the
All
next
of these
term?
values I can get off my triangles. Notice at no point in this problem am I actually finding the measure of angle x or the measure of angle y.
Yeah.
They didn't ask me to find any
So
angles.
we have to do the
Remember, the
opposite,
only
which
thing
is
I'm
to
looking for is the
subtract.
cosine of x plus y. So the cosine of x,
We wanna
cosine
keep
of x is
eliminating
4/5.
things from the side with the x's. 'Cause we want x all by
Cosine of
itself.
y is 5/13
Yep. There you go.
minus the sine of
And then
x
our last step.
times the sine of y. Oops. Which is, there we go, 12 over 13.
We have a
Right,
number
and now it's
times
just
x equals a
multiplying them
number.
together,
The opposite of
combining, so I end up with
multiplication is
20 over
division. We have a number
65
times x that equals a number. What's the
minus
opposite of multiplication?
36 over 65. And that's going to give me an answer of negative 16
Yes.
over 65.
You
I
can type
can't
that
reduce
there.
that,
You don't need to write that. That's
so
right.
that would just be my final answer.
I don't know what this is.
In the next example,
Divide by
very similar. They're telling us that both alpha and beta are in quadrant 3, and I'm trying to find the sine of the difference. So I'm going to draw my angles in quadrant 3. So here is alpha,
now, Sanaya. You have to multiply them. It's
There
not a
is
decimal,
my
this
beta.
is multiplication. 4 times 4 times
cosine
4 times
is
4 times
adjacent
8 times
over,
8.
excuse
A
me,
number to
cosine,
the
yeah,
next
is
power
adjacent over
multiplying
hypotenuse, so
it
that would
by
be
itself that many times.
negative 2 over 3. Remember, hypotenuse can never be negative, so that negative is just telling me them on the negative side of the x-axis. Over here,
Alright, I have a
tangent
parent-teacher conference I
is
have to go
opposite over adjacent. So if I'm on the negative side of the y-axis, this would be negative 2. If I'm on the negative side of the x-axis, this would be negative 3. Right, but a negative divided by a negative is positive. That's why we say the tangent is positive 2/3. Okay, I'm going to have to do the Pythagorean theorem here to find my missing side. So I'm just going to call this a. So I have a squared plus negative 2 squared is 3 squared. So that's going to give me a squared plus 4 is 9. So I have a squared is 5. So a is going to be the square root of 5. Now since I'm on the negative side of the y-axis, I'm going to call that negative root 5. And the only reason I'm putting those negatives in is because when I do this out, I want to make sure I have the correct signs for everything. So if I put them in now, I don't have to worry about it later. Let's go ahead and look at the other one. If I have call this c, and I've got negative 2 squared plus negative 3 squared is equal to c squared. Gives me 4 plus 9. C squared is 13, so c is root 13, and that's going to be root 13. Again, hypotenuse is always positive. So if I'm doing the sine of alpha minus beta, my formula says I do the sine of the first, cosine of the second, minus cosine of the first, sine of the second. So I've got sine of the first, cosine of the second, minus cosine of the first, sine of the second. The sine of alpha, so the sine is opposite over hypotenuse, so the sine is negative root 5 over 3 times the cosine of beta, so the cosine is going to be negative 3 over root 13 minus the cosine of alpha, so the cosine is negative 2/3, and I'm just putting parentheses because I want to be careful with my double negative there, and the sine of beta, sine is opposite, so that's going to be negative 2 over root 13. I should probably put parentheses around this too, although you don't have to. I'll go ahead and do that. Okay, so multiply my numerators together, I get 3 root 5 over 3 root 13 minus, a negative times a negative is positive, so this is going to be 4 over 3 root 13. So that gives me 3 root 5 minus 4 over 3 root 13. And if I go ahead and rationalize that, I end up with root 13, 3 root 5 minus 4. Root 13 times root 13 is just 13. 13 times 3 is 39. You can distribute that root 13 in the numerator, or you can leave it there. So those are some different examples of how you might approach a problem like that. And to me, that is very systematic. Draw the pictures, find your missing sides, and then use the information from your pictures to fill in the formula. Okay, a quick example on Actually, I will do the final 2 problems in the next video, so I'll kind of group those together. Okay, I'll see you in the next one. Thanks, folks.